So, Reetika, you can unmute yourself.
Good afternoon, sir.
Good afternoon.
Good afternoon, ma'am.
Good afternoon.
So, Reetika, tell me about your background and how do you pursue the statistics?
Good afternoon, sir. My name is Reetika Sahai and I hail from Meerut, Uttar Pradesh. I have completed my master degree in statistics from Meerut College, Meerut, and also an MPhil degree in statistics from Chaudhry Charan Singh University campus. After that, in the very same year, I got an opportunity to work with NSSO, FOD Dehradun. There I worked for WPI new series scheme.
And so, could you please tell me something about your college life in CCS?
Sir, it was good actually. The campus was very good, and I have learned a lot from that CCS campus.
Okay. And who was the role model while you were doing the statistics?
Sir, role model.
Was there anyone?
No, sir, there was a professor, which in my post graduation. So his name is Dr. Vikas Tyagi. So he was my role model, but not for statistics, I can say. It was like as a person and a human being.
Okay. And you have worked as the field investigator with the NSSO.
Yes, sir, in 2007,
So
16,
can you
17.
describe the process you followed for collecting the data during your time?
Yes, sir. So there, sir, we were provided with the listing of the manufacturing units of the manufacturing units. So we used to visit them and collect the data for a particular commodity in particular manufacturing unit.
What were the challenges? Was there any challenges faced by you?
Yes, sir. Sir, I have faced many challenges. Like even I have faced EFTs also in the field work. But yeah, it was quite tough and quite engaging and emerging experience for me.
Okay, now ma'am will ask you some of the questions.
Reetika,
Yes, ma'am.
presently you are working, no?
No, sir. No, ma'am. I'm not working right now.
Bangalore, that tutor, etc., is it not yours?
Yes, it was in past, like till COVID, I have worked as a tutor through platforms like Urban Pro and Flip Class.
But your current address also is given Bangalore address, no?
Yes, sir. I'm residing in Bangalore only right now.
But you are saying you are not working.
No, ma'am.
Actually, she is married, and so that's why she is there.
Yes.
Okay, I thought that you are working online tutor or something like that.
Hmm.
There, what you were teaching when you were working with online tutor?
Yes, ma'am. So I was taught subjects like mathematics and science from 5th grade to 8th or 9th grade till.
Online you are teaching.
No, offline actually, ma'am. I used to travel across Bangalore, but limited kilometers.
5th to 8th maths you are teaching.
Yeah, maths and science also I have taught.
So, but after 4 years gap, you are trying for ISS?
Yes, ma'am. From COVID period, I have ample time in COVID period, so I regain my knowledge and collect books, syllabus, and started to collect information about this exam. And since then, I am preparing for this exam.
This is the first attempt.
No, ma'am. This is my 4th attempt.
Okay. So you have been trying very hard.
Yes, ma'am.
Good. It should be like that. So this time, what were your fourth paper specialization?
In my fourth paper, I opted for DOE and SQC, Design of Experiment and Statistical Quality Control.
Oh, can you tell me something on statistical quality control?
Yes, ma'am. So, ma'am, for any, if whether it is service or whether it is product, the quality is a foremost region we have to ensure. So, statistical quality control provide a basis for quality, for controlling a for the quality of any commodity, any services, and that need to be addressed before we deliver some product or service.
So how do you measure the quality for services?
Yes, ma'am. So there are some tools and for measuring the quality of a particular product or services, and some of them are quality charts, statistical control charts are there. So this is and also root cause analysis is also there in statistic quality control. 5 whys are there.
No, suppose I am giving the services of education. Then how do you measure the quality of my education services?
We can conduct a survey, ma'am, where the service is providing, and we can take the feedback. We can prepare cross diagram like against age, gender, like this. We can conduct some IQ test also.
That IQ test of the student, then the quality of teaching you need to measure.
Quality of teaching, no, ma'am. IQ
Service
test.
are providing the service of teaching.
Yes.
I want to know the quality of teaching.
Teaching, okay.
So how can you measure it?
So we can ask from the students itself some IQ test because the IQ of a student like directly depends on the level of teaching. So in as a whole measure, we can construct some survey, or we can construct some charts also.
Isn't it a biased one if the student gives the feedback?
It's maybe, but as a whole, ma'am, we can have a picture like.
Okay.
Yes.
And what are the components of an index? Major components of an index.
Of an index.
An index means what do you want to prepare an index?
So, ma'am, base should be there for comparing any particular index.
Okay.
And the current values which we want to compare with the base per year.
Okay.
And rest, ma'am, I'm not able to recall right now.
Don't you require item basket?
Yes, ma'am.
Depend on that.
Yes, ma'am.
So
Definitely.
if your items are not representative,
yes,
then what will be the quality of your index?
Yes, ma'am. It should be predefined.
Okay.
Yes.
And what is the base year of the current price indices?
For CPI, ma'am, consumer price. So for CPI IW, it is 2016. CPI agricultural labor and rural labor, it is, I think, 1986 to 87. And for CPI rural urban combined, it is 2011-12.
Okay, not 11, 12, 12 it is.
Sorry.
And for IIP, what is the base year?
2012.
Okay, all the best.
Thank you, ma'am.
Come out of the.
Now, sir will ask you some of the questions.
Hello.
Good afternoon, sir.
Are you comfortable any subjects? Any topic?
Yes, sir.
Design of express you are telling, na? What will be confounding?
Confounding, sir. So, sir, when we are conducting design of experiment, when our block size is very large, So it is very hard to measure the effect because as we increasing the number of treatments, so the number of combination will also increases. So so the less important effect we can confound in the process of confounding. So
What
it's
is partial confounding?
sorry, sir.
What is partial confounding?
In partial confounding, like we in different blocks we confound different effects, and
How
in
do you come to know? Any procedure is there? Which factors are confounded?
so say there are some rules, or like, there is a formula like which should be confound if we have some sir, sorry, I'm not able to recall the exact formula, but there is a formula. Like,
Doesn't matter. What is BIBD?
so sorry, I should not say this, but this is not the part of syllabus, so I
Actually, it was
haven't.
not the
BIBD is not
syllabus.
there. The course.
Yes, sir.
Doesn't matter. So, okay, it's okay. So, can you give an example of a 3x3 lattice square design? What is lattice square design? What do we first define what is lattice square? When you say it is a lattice square design?
So, sir, in lattice square design, we control the variability in two directions, in block-wise and row-wise also, because the fertility gradient is there, and we can have a misleading result due to this fertility of soil, if we say in the field experimental design. So, we consider LSD to control the two-way variation, block-wise, row-wise and column-wise.
Is there any restriction about the treatments, how they should appear in the design? Is there any rule?
Yes, sir. So the number of treatments is equal to number of rows and number of columns. This
That's
is the one of this, and there is square. It should be almost approximately square plot on which we be conducting the experiment.
You could not approximately because lattice square. That's
Yes.
a square design. Not
So it should
approximately.
be strictly square.
Okay, suppose the first row A, B, C.
Okay, sir.
In the second row A, C, B. Third row B, C, A.
Okay.
A, B, C,
Mm-hmm.
A, C, B, B, C, A. Is it going to be lattice square design?
No, sir, because in first row and at the position first row and first column, the block is the cell, and we repeated A in the first column.
It means treatments should occur only once.
Once in a row and once in a column.
That is important.
Yes, sir.
Okay. So, what is local control? What do you mean local control? What is the purpose of local control?
Sir, to minimize the random error as much as possible in two-way factors, row-wise and column-wise.
Okay. So, you have done inference also. When do you apply t-test? Design of experiment, you apply t-test. T-test for difference of treatment means you have done.
Yes, sir.
T-test. What do you mean t-test? What are the conditions involved to apply test for difference of means? Maybe treatment means. Whatever is there.
Sir, observation should be independent, and second one, observation. Sorry, sir.
Is there a relation between T and F?
Yes, sir. Yes, sir. So T square is a F.
T square. But F is with the N1. F should have two terms of freedom, na?
Yes, sir.
N1 and 2. Then T square is equal to F, you are telling.
Yes.
What is the degrees of freedom of T?
And sir, if we have a T square with V degrees of freedom, so it will be F with 1 comma V degrees of freedom.
So Similarly, you know the relation between chi-square and F.
Chi-square and F. Sorry, sir, I'm not able to.
F test, when do you apply F test?
Sir, for testing the difference of two population means in like ANOVA, we use F test.
Two difference of means T test also can use, no?
Yes, sir. For several means, F test can be applied only.
F test. What is a Bartlett test? Bartlett test. Did you hear the word?
Yes, sir. It is used for testing several population variances.
Homogeneity. Achha. What are the uses of chi-square distribution?
So for goodness of fit, we test as a chi-square, and to test the goodness of observed data also, and chi-square is also test for sample. Sorry, I'm not able to recall.
What is the parameter of a chi-square distribution?
Sir, degrees of freedom. It's degrees of freedom.
What is the mean of chi-square distribution? Mean, variance?
Mean of if it is if chi-square is if n degrees of freedom, then mean is n and variance is 2n.
So, what is the difference characteristic function and MGF function?
Of chi-square distribution.
MGF and characteristic. No, for anything. General.
Okay. So if we talk about moment generating function, so it help us to generate the moments, whether it is mean, variance, beta 1 for measure the skewness and kurtosis, we can obtain from the MGF. And so characteristic functions are the use is we
You also
calculate.
get to characteristic function, all these things. But there is superior quality about the characteristic function.
So it is always exist, characteristic function. There are some.
MGF always doesn't exist.
No, sir.
Give an example of where whatever distribution you have studied, where MGF doesn't exist.
So for Cauchy distribution, it doesn't exist.
Does it characteristic function exist?
Sorry, sir.
Cauchy population.
Yes, sir.
Is a characteristic function exists?
Yes, sir.
Achha. What about MGF of T distribution?
MGF of T distribution, sir. No, sir. It doesn't exist for a T distribution also.
What is the, how do you say that mean, mode, median? How do you say positively skewed? When do you say it distribute positively skewed?
Can I take 1-2 seconds, sir?
What do you skewness, first of all? Skewness is what?
So, sir, it tells us like how the data is clustered around, whether it is we have more values, positive values, or we have more negative values, like whether which side it is more clustered, data is clustered. So you asked for positively skewed distribution. Okay. So, sir, if we have mean, median, mode, so median always lie between mean and mode, and mean should be greater than mode for positively skewed distribution.
So, like that, with dispersions, you are able to tell.
Yes.
With moments also can say. What are the uses of moments?
Movements also tells the shape of the distribution and the data. So whether it is skewed or not, whether it is peaked, or how is the shape of the distribution, they can tell us.
Okay. Through moments, can you talk about the dispersion and anything? Can you talk of dispersion? If I know the moments.
Yes, sir.
Can I get variance?
Yes, sir. For second central moment, we can directly have a variance mu2.
So by using the moments, how do you come to that negatively skewed, positively skewed?
So, sir, there is a formula for positively skewed or negatively skewed. If we calculate first of all moments, and then beta 1 is mu3 square upon mu2 cube. So, if it's come out to be positive, then it is positively skewed. We first take its under root. We calculate gamma 1 also for the skewness.
If you take under root, do you get the symbol? Negative sign you'll get. Suppose if I'm giving some value, beta 1 is equal to 0.36.
0.36. Okay, sir.
What is root gamma 1? Gamma 1 root beta 1, na? Gamma 1
Yes.
is, what is that value? 0.06. 6 by 100, na?
Yes, sir. 0.6.
0.6. 0.6, na? Okay.
Mm.
Then, how do you say it is a positive skewed, negative skewed?
So because our beta 1 is positive.
So that means no negative skewed never exists, na?
No, sir. The
No, you need not go for till beta 1. Because if mu3 is negative, skewness is negative.
Yes, sir.
You are taking mu3 square by mu2 cube, na?
Yes, sir.
mu2 is always positive. Why?
Variability cannot be negative, sir.
So mu3 may be negative, positive.
So
Which
mu3
value?
can be negative, but it's a
Or
square.
positive.
We take it square in the formula.
If you take the square, when you go back to square root, will you put
Mm.
negative sign or positive sign?
So it depends actually on the original.
No. Better if original quantity is negative,
So we should
take the
consider.
square. Always positive. When you
Yes,
come
sir.
back, you
We
put
should.
negative sign only. Why is it plus or minus so and so? As long as you do not know, plus minus you will put. Once you know quantity is negative, it will come negative only, na?
Yes, sir.
Suppose one regression coefficient is positive,
Regression. Yes, sir.
other regression coefficient is negative.
One positive, one negative. So they should be always the same sign for both the regression coefficients.
Sure? Correct.
Yes, sir.
Then what will be R?
So
R,
for
coefficient of correlation, what is the value?
same sign for the if both are positive, then correlation also positive. If both are negative, then correlation will also negative.
But how do you get the value of R? Square root
R
of?
is yes, sir. R is under root byx into bxy.
If both are negative, when you take the square root, that negative goes, na?
Yes, sir.
Then when it comes to then while putting the sign of R, what do you put, negative or positive?
So because initially we have regression coefficients and negative.
Because regression coefficient negative, you put negative sign.
Yes,
Similarly,
sir.
original quantity is negative. Even if you take the square root, you have to put back to the negative sign only.
Yes, sir. We should
This is
consider
why
this.
if mu3 is negative, skewness is going to be negative.
Yes, sir.
So if I ask you what is the value of skewness coefficient, beta 1 arises. But skewness negative or positive, by moments you can see it and tell. mu3 0, no skewed.
Yes, sir.
mu3 negative, negatively skewed. mu3 positive, positively skewed.
Yes, sir. We can
Do
tell.
not go to the beta 1, etc. Go back. If you go to beta 1, you will get confusion.
Yes, sir.
Then you positive risk, negative risk, you cannot understand through beta 1. Because you get doubt now, always you are telling positive sign.
Yes, sir.
Be careful.
Okay, sir. Thank you, sir, for the information.
So because this type of simple things, unnecessarily you get confusion. Basic things. Statistics starts from this basic mean, mode, median moments only.
Yes.
BABD, inference, be the basic fundas.
Yes, sir.
What is the difference between simple correlation and multiple correlation?
So in simple correlation, we consider a set of data like X and Y only. So there is two variable we can say. But in multiple correlation, we we see there is one dependent variable and other are independent variables. So we want to see like how much independent variables impacted the dependent variable in multiple correlation.
So R square, what does it give? Capital R
R,
square.
R square says multiple correlation. Sir, it is we can also say it as a model adequacy. If R square is suppose 0.95, so we can say our model is 95% good. We fit it the 90% fit good model.
How do you split total sum of squares?
It's depends like sum of a square due to treatment and plus the sum of square due to error. More the component will be add in the right hand side.
So more and more values are more and more variables are added. Does it increase R square?
Yes, sir. It
So,
will.
but adding variables like principal component, so many variables, adding so many variables, is it going to be helpful or costly experiment?
No, sir. It sometimes gives us false impression, and if the variables are particularly irrelevant to our model, so in that case we calculated adjusted R square.
Right. What is adjusted R square? How do you say that adjusted R square corrects this one?
Sir, by I don't know the exact reasons, the practical reasons.
Adjusted R square will tell.
Yes,
Okay.
sir.
What is the bias in regression? Bias in regression.
Bias.
How to define bias?
Hmm.
How to define bias of an estimator? How do you define?
Sir, difference between true value and the estimated value.
Yes.
Error.
So that is also called in survey. What do you call?
Error, sir.
Sampling error.
Sampling error, sir.
Okay.
No. So there is.
Tell me.
Yeah, so there can be sampling error or non-sampling error as well.
What do you not sampling error?
So non-sampling error arises due to some other reason except sampling. Like if we conduct census or sample, there will be definitely non-sampling error like negligence of the field investigator, some defective techniques if we adopted for collection of data, any mistabulation or this kind of errors, we can say them non-sampling errors.
Okay, good.
Okay, then,
All the best.
Reetika. So it was good talking to you, and
Thank you.
provide you the feedback over this session, and
Yes,
it will be informed by the tomorrow.
okay, tomorrow, sir,
It will be informed by the tomorrow that when will be your feedback session.
Okay, sir. Okay.
Oh,
Okay. Thank you, sir. Thank you, everyone.
oh.
Yeah.